So here's an example with a 3-circle Venn diagram. So let's take a look at this. Out of 35 students in a finite math class, so that's going to be our universal set, I know that 22 are male, 19 are business majors, 27 are first-year students, 14 are male business majors, so now we're kind of seeing some overlap, right? I had male business majors and first-year students. These are my 3 groups, but now I have 14 that are both male and business majors, 17 that are male first-year students, 15 that are first-year business majors, and 11 that are male first-year business majors. So first thing I want us to do is I want us to complete this Venn diagram. Remember I said to work on your outside in. So, from the inside out. I forget my own sayings. So the first thing I need to know is I need to know what my groups are. So my groups are male. Why don't we represent that with a M? Business majors will represent that with a B, and first-year students will represent that with an F. Remember, my universal space is my finite math class, which is where we're drawing our samples from. So the first thing I know is I have 11 first-year male business majors. So here I have male, business, first year. 11 of them are in the center. So that's done. Next, 15 are first-year business majors. So that means that 15 of them are going to fit in this little intersection area right here. Well, I already have 11, so in order to get 15, I just need 4 more. Next, I have that 17 are male first-year students. So that means 17 of them are going to be between male and first year in this little section right here. Well, 17 is 11 plus 6. Cross that off. Next, I have 14 that are male business majors. That's going to be that overlap right here. So 11 plus what gives me 14? That's going to be 3. Next, I know 27 are first-year students. So how many first-year students in F do I have already? I have 6 and 11 and 4. That gives me 21. But I have 27 first-year students. So 21 plus 6 gives me 27. And now if I add up everything in F, we would get 27. Next, I have that 19 are business majors. I already have 11, 3, and 4 business majors. That gives me 18 business majors. So I just need 1 more. That'll put me up to 19 business majors. And then of my class, 22 are male. So I already have 3 plus 11 plus 6 males in first year. 20 in males. So I have 22 that are male, so I need to add 2. Now, my class has 35 students in that. Are all these students represented so far in our Venn diagram? Well, I need to check. I do that by adding up every region, and I'm going to work from right to left going down. So I've got 2 plus 3 plus 1 plus 6 plus 11 plus 4 plus 6. And that gives me a total of 33. So that means I have 2 students that are not males, first years, or business majors. They meet none of that criteria, so they're outside of that. So awesome, we completed our Venn diagram. Good job, team. Next thing I want to know is how many students are neither first years nor business majors. Okay, so I don't want any first years, so I'm going to ignore what's in here. I don't want any first years. I also don't want any business majors, so I'm also going to ignore what's in here. Right? So how many students are not in these 2 green circled regions? Well, that's going to be 2 and 2, so I just have 4. Next, I want to know how many non-male business majors there are in the class. Let's pick a nicer color than red. We'll use orange. So I want business majors, that's going to be B over here, that are not male. So I don't want to look at any of this. Well, how much then is left in business majors? Well, I've got 1 and 4. That gives me 5. So there are 5 non-male business majors in the class.